Hello, how are you? Today we are going to solve a question which states that shows that y equals to a e power 2x multiplied by cosine of 3x plus a constant epsilon is a solution of the differential equation the second derivative of y with respect to x minus 4 multiplied by first derivative of y with respect to x, then plus 13y equals to 0. So we are required to show that this one is a solution of the differential equation, this one where epsilon is an arbitrary constant. So how to solve this? The purpose or the way of solving this is by removing the constant from the given equation. We know that in this equation we have y. This y is a dependent variable in which the value of y depends on the values of x, while we have a logarithmic function e, and also we have the trig function here, and again we have x, and here x. This x is a independent variable in which its value does not depend on the value of y. So another one, we have a constant here, so we have two constants, we have a and e. We're going to remove these constants and they have an equation with independent variables and dependent variables only. So solution given, we are given y equals to a multiplied by e power 2x, then multiplied by cosine of 3x plus epsilon. So this equation we are supposed to differentiate it, so we're going to differentiate it twice because here order of differential equation is 2, or in other words you can say it is a second order differential equation. So we're going to differentiate the given function twice. So let us see, or let us differentiate or find first derivative. So derivative of y with respect to x is the same as differentiating this function a e power 2x cosine of 3x plus epsilon. Differentiate it with respect to x, it is the same as this one. So here derivative of the function y with respect to x is equal to, remember that this one is a product. We have product of two functions. We have the product of first function, this one logarithmic function, and again we have a trig function here, so we are going to use the product rule. So I'm going to differentiate directly by taking derivative of this one and keeping one constant, or derivative of this one and keeping the other constant. So we differentiate one function and keeping the other function constant, and again we plus differentiate the other constant and keeping other function constant. So let us start with keeping a e power 2x a constant. So here keeping this, it will be a e power 2x constant. Let us differentiate cosine of 3x plus epsilon. So derivative of this one is the same as differentiating this angle and then multiply by the derivative of the cosine of this angle. So if we differentiate this angle, we will have 3 here, 3x plus epsilon. Differentiating it with respect to x, it means here the answer will be 3 multiplied by derivative of the whole function, trig function, cosine of 3x plus epsilon. It will be negative sign of 3x plus epsilon, so negative will come here, and then we'll have sign of 3x plus epsilon. So we have kept this a e power 2x as constant. We have differentiated this one, and then it is the time to keep cosine of this angle constant. Then we are differentiating this. So here derivative of a e power 2x is the same as derivative of this power here 2x, then multiply by the whole function. So derivative of 2x, it is 2 multiplied by the function a e power 2x, and then we have kept constant, so it will be cosine of 3x plus epsilon here. So this is the derivative of the function. Let us arrange it properly. So here we have got negative 3a e power 2x sine of 3x plus e plus epsilon, then plus 2a e power 2x cosine of 3x plus epsilon. So as we can see here from the given equation, here y is equal to a e power 2x cosine of this one, and again here in our function we have a e power 2x cosine of this one. So we can say but y is equal to a e power 2x cosine of 3x plus e. So we are going to substitute y in the position of the a e power 2x cosine of 3x plus e epsilon, or in other words that we are going to substitute or to place y in this position here. So the question will be dy dx is equal to negative 3a e power 2x sine of 3x plus e, then plus 2. Remember that this one is the same as y, so it will be 2y. After that, so this is the first derivative. Let us call it equation 1. After that, let's differentiate it again for the second time, so it will be second derivative of y with respect to x equals to the derivative of negative 3a e power 2x sine of 3x plus epsilon, then plus 2y. So derivative of this or expression with respect to x for the second time. So here second derivative of y with respect to x is equal to, here 3, it is constant, let us keep it out. So inside we will have a e power 2x sine of this one. So we have two functions here. The first function is the logarithmic function and the second one is the trig function. So we have to keep one constant, differentiating the other, and then doing vice versa for the second time. So here let us keep a e power 2x a constant, so it will be a e power 2x constant. Differentiating this, it will be multiplied by 3 derivative of this one angle here, it will be 3 multiplied by derivative of sine, it will be cos of 3x plus epsilon. So this is the derivative, keeping constant here is this one, this is the derivative of this one, and then plus, let us keep sine 3x plus epsilon constant. So here we differentiate a e power 2x, in which derivative of a e power 2x, it will be 2a e power 2x, then this sign is constant, sine of 3x plus epsilon, and then we have finished here differentiating here, so differentiate this 2y, in which derivative will be equal to 2 dy dx. And remember here we have bracket for this negative 3 here, in which bracket will be here, and then 2 dy dx. So let us arrange it properly. Second derivative of y will be equal to, open here, it will be negative 9 and a e power 2x cosine of 3x plus epsilon, then minus here negative 3 and 2, it will be negative 6 a e power 2x sine of 3x plus epsilon, then plus 2 dy dx. So after that, let us set it like this. Dy dx square is equal to, so if you look careful in this equation here, we can see we have negative 3 a e power 2x sine of 3x plus epsilon e. We have this one, and we can use it to replace, we can use this equation to replace a certain function in the, so we can use it to replace here where we have function of the sine of 3x plus, and here again if you look careful here we have a e power 2x cosine of this one, we can see this one is the given function y. This is the function that we were given, so we can replace it. So let us arrange it properly. Here we have negative 9 ae power 2x cosine of 3x plus epsilon, then plus, here we can take out 2, inside it will remain with 3ae power 2x sine of 3x plus epsilon, then plus 2 dy dx. So from this equation number 1, we can see here we have dy dx is equal to negative 3ae power 2x, the sine of 3x plus epsilon, and then plus 2y. So at the same we have here negative 3ae power 2x sine of 3x plus c. So we can take this one, make subject this one, and come to replace in this place. So making subject it, we'll have dy dx minus this one is positive, so come to this side, it will be negative, minus 2y, which is equal to negative 3ae power 2x sine of 3x plus e. And again here we can see this one is ae power 2x cosine of this one, which is the same as y. So here we have this expression negative 3ae power 2x sine of 3x plus epsilon. This one is the same as writing dy dx minus 2y, and again ae power 2x, this one cosine of 3x plus epsilon, is the same as writing y. So we're going to substitute these two equations in these positions. So after substituting here, we'll have second derivative of y with respect to x equals to negative 9y, then plus here open bracket by 2, it will be 2 dy dx, minus here open by 2, it will be 4y, and then we have 2 dy dx. So again here we are going to combine the like terms. This one will be combined with this, and this one with this. So second derivative of y with respect to x is equal to this, and this will be negative 13y, and this will be plus 4 dy dx. So we're going to shift all of this to this side, so it will be second derivative of y with respect to x is this one is negative, so to the other side it will be positive 13y minus 4 dy dx. In this side will remain 0. Let us arrange it in order of decreasing the order of differential equation. So here it will be second derivative of y with respect to x minus 4 first derivative, then plus 13y is equal to 0. So we say that since derivative of the function y with respect to x, the derivative of ae power 2x cosine of 3x plus epsilon, since derivative of this has brought us the first derivative and second derivative, has given us this result, which is the same as the differential equation. So we say that this one, the equation y is equal to ae power 2x cosine of 3x plus epsilon is the solution of the given differential equation. Thanks for watching.